Hello everyone, this is a second lecture which is in continuation of a previous lecture in which I have introduced an overview of what is GIS. As you know, each and every system having different components. So GIS, if you take say example of a pencil, then pencil having two major components, one is your graphite, another one is wood. Similarly, in GIS, we are having different components. One more important thing which I would like to bring, in the previous lecture I have touched little bit about coordinate geometry. The basis of GIS is completely mathematics, but in this course we are not going to go into the details of mathematics, but how mathematics in background is working for us. Time to time I would be definitely bringing those points. Like yesterday or in previous lecture we have discussed about coordinate geometry, the mathematics on interpolation, the mathematics on set theory, mathematics on different aspects of polynomial equations and other things all are used in GIS. So, everything in the background is based on mathematics, but on front end we do not see those things except the user interface. So, let us go into the deep now, starting with different components of GIS. GIS is if you see different literature or books or on web pages, you would find people will describe maybe 5 components, 6 component and so on and so forth. But I feel that we can very well segmented GIS into 5 major components, and these components, as you know that in the previous lecture also we have discussed this figure, that because the real world we are segmenting or discretizing into different layers, and in order to do that so that we can achieve towards the analysis or modeling or prediction, we need to have different components. So, the first component, because if you recall the definition of GIS, it is mentioned that it is a computer based information system. So, it has to have a software as well as hardware. So, you know that hardware is a computer on which GIS operates. Now, this is very interesting. Nowadays, it is not necessary that you should have supercomputers, mainframe computers or big computers for GIS analysis. Even on smart mobiles, a basic GIS can function. So, GIS for the hardware, a wide range of hardware is available on which GIS can run. There are software which are high end software or sort of big softwares which requires workstation, and the same software, a strip version of the same software can run on your palm top or laptop or even on your smart mobiles having say Windows operating system or Android as well. So, hardware nowadays GIS is available on all kinds of platforms, and keep the example of previous lecture about like Google Map or Google Earth. Google Map is also available on variety of platforms. So, you need to have hardware, and as you know that hardware runs on wide range of computers, and from centralized computers on servers, desktop computers, standalone network configuration, all kinds of combinations are available now. So, hardware is one of the most essential as per the definition of GIS, the first component. The next one comes the software. This is another very important component, because without having software you cannot have real GIS operations. Here I would like to give one analogy which is very interesting, and the analogy is that GIS is something like a carpenter's toolbox. Someone may surprise with this analogy, but let me explain that you go in the market and you can buy a carpenter's toolbox, but you will realize very soon that the carpenter's toolbox having different tools. For example, it is might be having hammer, saw, or maybe drilling machine and so on and so forth. But the carpenter's toolbox will not have design. will not have the raw material. So this is very important. Similarly in GIS, though you may get hardware, you may install a GIS software, but if you don't have the data, which is our next component, then it is useless. And if you don't have designs, like for a carpenter, if he doesn't know how to prepare a chair, then the carpenter's toolbox is useless for him, even if he is having wood. That means the material, and in our GIS parlance we can call as data. So all these 5 components are most essential and have to be there together, then only GIS can function. So the second component, that you need the software to run your GIS operations. So these provides functions and tools needed to store, analyze, display geographic information. That is the main purpose of your softwares. Now similarly, like GIS softwares are available again on wide range of platforms and wide range of operating system. As time is passing, when GIS was invented by Roger Tomlinson, at that time it was on DEC machines. You have to have their operating system were altogether different, maybe Unix or some other operating system. Later on, most of the now most popular GIS softwares are now on Windows machines, which are having very powerful set of tools, and most of the tasks which you can think in GIS can be performed on these Windows machines, maybe running on workstation or even on laptop. So the software is basically the purpose of these softwares, GIS softwares, as displayed here, that to store, analyze and display geographic information. Remember, all the time everything is related with coordinates, geographic coordinates, location specific coordinates. So everything which we are handling, which is the unique thing in GIS, which is not common in CAD machines or CAD/CAM softwares or other technologies, but only GIS provides that functionality to use geographic coordinates. The key software components within the software, the components which we look in GIS software, like for input of the data, we would like to bring the data, because by definition data might be coming from variety of sources, and therefore your GIS software should be capable of receiving data from variety of sources. Here variety of sources, as mentioned earlier, that maybe the field data, maybe the remote sensing data, maybe the data coming from some Excel sheets, maybe from some already existing databases, or maybe analog data which has to be converted into a GIS platform. So the input capabilities, a good GIS software should have very good input capabilities. Sometimes we have to even key in the data within the GIS database. Now also it should allow us to manipulate the geographic information. Manipulation does not mean that we are corrupting the data. Manipulation means changing from one format to another. For example, like from analog to digital, one format, digital format to another format. Like in images we do, sometimes we get images in TIFF format, we convert them to maybe JPG format or IMG format, depending on the requirements of individual softwares. And then your another key component within the software is the database. So good GIS software should support a very good database management system. Third is the tools for support geographic query, because ultimate aim after developing this database, bringing the data inside the data, organizing the data in an efficient manner, then comes the query, analysis and visualization, output which you are looking. So your GIS software should support all these things. And the last in this one is that it should have, nowadays it is required, in earlier versions everything was through command mode. So everything has to be typed. Now all it is through Windows or GUI interface. So you are having easy access to these tools very easily. One very important question comes here, that suppose somebody is looking that okay, he will start working on GIS, because the projects or the problem on which he is working, he feels that he can use GIS to solve those issues. Now the next question will come in his mind, that which software, because in a previous lecture I have mentioned there are hundreds of softwares available. So which software? Now I can give you some criteria on which one should judge and then buy or arrange those softwares. The first criteria in my opinion is that the software should be in modular fashion. That means today you are having certain amount of funds, you buy the software. Now tomorrow you are having more requirements, you are having again some funds available, so you buy another some add-on or modules which can very well gel with your existing basic installation of GIS software. Another very important thing with the GIS softwares, that you should have good help available. Nowadays most of the very popular GIS softwares are having either online help or offline help available through but if the softwares which are not providing online help, then I would not put them in a very good category of GIS softwares. Another very important thing is that because sometimes locally you may not be having expertise available within your organization. So you sometimes when you are stuck in GIS in real projects, this is a very common thing, that initially when you start working in GIS platforms, you find sometimes difficulty while inputting the data, organizing the data or analyzing that. Then you would look for help. Online help or offline help may not be sufficient. So you would look some help through some persons. So these softwares, GIS softwares should also support some discussion group. Nowadays good softwares are having their own discussion groups, so that you can raise your question and within few hours, maybe 24 hours later, you get the good answer, good reply, good support from these discussion groups. Sometimes you can also contribute or help others if you know the answer about that particular problem a person has raised. So these are the certain criteria one should keep in mind when going or selecting a GIS software. Now third, and in my opinion again very important component, is the data. As for the carpenters, is a wood or material which he will use to prepare a furniture. Here we will make maps or tables or reports. Without data you may be having good hardware, you may be having very most popular and most advanced GIS software, but if you do not have the data, it is no use. So data is another very important, and that is why it is mentioned here that possibly the most important component of GIS is the data. Without data your GIS cannot run, like without wood a carpenter cannot work. Now GIS data and related the tabular data, which I will come later, which we call as non-spatial data, geographic data we call as a spatial data, can be collected in house as by definition coming from variety of sources. So one might be in-house collection or purchased or available through some sources. So data can come from variety of sources in variety of formats, and that is why manipulation, format conversion, all kinds of conversions may be required in case of the data. Now the fourth and another important component, the people. Without people, now people includes both the GIS experts and users and decision makers. All kinds of a full spectrum of people are required in a GIS. Otherwise, if nobody is asking new solutions from GIS, then development of GIS will stop. So you require as a user send, purely as user send. They do not know how GIS works. They do not know from where the data has come. They do not want to bother that how you have organized the data. They just want to see the results. Like most of the people are using Google Maps without knowing from where the data is coming, who is generating the data. They are just simple users. People also include the GIS experts, those who collect the data, organize the data and maintain such systems. Maybe online systems like Google Map, or maybe offline systems in some organizations or large enterprises. So people are another very important component of GIS, and GIS technology will be limited, as I have already mentioned, without the people. and who will manage the system, develop plans for applying it to the real worlds, and the real users who would really exploit the GIS. And GIS users also range from technical specialists who design or write codes, develop the software further, and those who keep asking questions to the GIS expert that can you do this thing. And also mentioned in previous lecture that is a continuous process. GIS operations are continuous. You keep developing something, people will keep asking more, and as you develop more they will keep asking. So, they will compel the development. This is how the GIS has developed. So, it is in many ways it is good. Another very important thing, when we start looking little bit to the first component, the hardware or computer technology overall, which also include the software technology, that more developments when they are taking place in these two, hardware and software, slowly in after some time these development will also come into the GIS platform. So, the development in any such fields ultimately will also percolate into the GIS domain, and more hardwares are improving and becoming better, faster, and are capable of handling large volumes of data, then our GIS also becomes rich. If softwares becomes very efficient, new algorithms are developed, new tools are there, then slowly all these will finally ultimately also will percolate into GIS domain. So, we are GIS is getting benefited from all sources, whether it is a cartography, any development takes place in cartography, ultimately it will percolate into GIS. Any development in computer science, software, hardware, or in communication, that too will come. Similarly, like in GPS technology, few years back we had only one global positioning system which was US based. Now we are having several, including India is having our own GPS system, like which we recently it has been renamed as NAVIC. It was IRNSS system, and it is a regional system, whereas GPS or GLONASS are global system. Chinese have also developed a system which is called Baidu. So, that is global system. Now, a GPS receiver which used to receive only signals from US based GPS or global positioning system may not be used in future. Now, people are having receivers which can receive signals from 3-4 such systems. Therefore, the accuracy will improve, and this improvement in accuracy ultimately will also percolate into GIS. New applications also will develop in GIS. One very important thing which in GIS regularly, including in remote sensing, digital image processing we do is georeferencing. We geocode a satellite image. So, because nowadays we are moving from higher and higher resolutions, and therefore very high quality or very accurate georeferencing is required. So, conventional methods of georeferencing may not work now. So, we require very high accurate data from GPS, and luckily all kinds of navigation systems are now available. So, we can definitely improve our accuracy of georeferencing. So, what I am trying to say that development in computer technology, development in GPS technology, development in remote sensing technology, development in cartography or CAD/CAM design, all finally will also percolate into GIS domain. Fifth and last but not the least component of GIS is methods. Again, let me relate with the same carpenter's toolbox analogy. It is the design of a furniture. How to cut a wood, how to polish a wood, how to make a hole in the wood, which wood would be most suitable, where one can find the wood. So, all these methods are very much required. In GIS, like algorithms are there, and as I have said that most of the things are coming from mathematical domain. So, if anything develops there, if it has got use in GIS, it will come in GIS, maybe little later, but Definitely it has come. So methods or designs are very, very important in GIS. Now a successful, as I mentioned here, that a successful GIS operates according to a well designed plan and business rules, and which are the models and operating practices unique to each other. Let me give you one example. Like somebody, if he is working on say groundwater flow, a new model on groundwater flow estimation has come. It does not have so far any linkage with GIS, but very soon in future it will have a linkage, and once it develops the linkage, that model itself becomes very powerful, and so GIS becomes enriched because of the linkage which has been established with that model. And this is how initially all these models are developed in isolation. One more example I can give, there is a very famous model which is called universal soil loss equation model. So this model was existing before the invention of GIS, but once the people have clubbed it or integrated with GIS, that the same USLE or universal soil loss equation model or revised version R USLE and other things have become much more powerful, much more useful once they got the linkage with the GIS. So there might be some tools available, models might be available in isolation, there may not be any linkage so far with GIS, but in future in my opinion they will have very good linkage if they handles the geographic data, and then the tool itself or the model itself becomes powerful, so the GIS. So that is the now in methods about inputting the data, methods about organizing the data, methods about the changing the format, methods about the georeferencing, accuracy parts, and then finally analysis and modeling. So these sections of software, GIS softwares slowly are also becoming very enriched. Let me give you one more example. Like GIS handles large volumes of spatial data, and sometimes you require data compression techniques. Now data compression is a part of mathematical domain. So more developments as they are taking place, more new technologies which they are implementing in data compression ultimately ends up in GIS. For example, wavelet based data compression techniques, they have now percolated into GIS softwares, and your GIS softwares will compress the data, or sometimes one has to buy a different compression tools available elsewhere, you compress the data, decompress the data. So though say altogether a different domain or a branch of mathematics, but the benefits which are being developed in mathematical branch of data compression also are coming later on, little later into GIS platform, so in image processing or remote sensing as well. As mentioned in the first lecture, that we segment the natural world into different components, different layers, different themes, and this is how that we organize the data into geographic, means we attach the location with each object. The object may be point data, object may be the line data, polygon data, or maybe a image, satellite image, or a photograph, or a video or audio. Everything we try to attach with the coordinates, and those coordinates are geographic coordinates. In our domain we call as maybe latitude, longitude, or in some other map projections may use different coordinate system, but all will fall in the geographic coordinate. And all these layers are organized in that fashion, and then reference, the georeference I have mentioned already. So it is a reference with the coordinate, geographic coordinate, so that we can stack all layers top of each other, and whenever we want to use out of say I am having in my database 20 layers, I want to use 2 or 3 or 4 at a time, I can very well use in GIS once they are georeferenced to the geographic coordinate system, any coordinate system which we can use, means any projection system I mean here. As mentioned also earlier, that the geospatial data or the data which goes into the GIS can be divided in two major parts. One is which is spatial data, which is having real the object location. For example, you are having a location of a house. Now, location of house is having x and y coordinates, maybe also z coordinate, but z coordinate is will go as a non-spatial data. How many people are living that house, who owns the house, when it was constructed, all kinds of information will go into non-spatial data, and spatial data is having just location. So, I gave the example of point data, it will have just x and y. If it is a line data, it will have a series of x and y, and if it is a polygon data, then it will have a series of x and y, but the first coordinate and last coordinate is going to be the same. So, like in case of satellite images, the location of a pixel will become your spatial data, what the value of the pixel will become your non-spatial data, or also we called as attribute data. And the spatial data will answer your question that where is it, the location, because it is holding the location of an object, whereas your non-spatial data will answer the question like what is it. So, likewise we keep organize the data in a fashion in GIS in a manner, so that we can retrieve very efficiently, we can analyze in a very coherent and nice manner. Now, as you know that this thing we have touched little bit, that the real world we try to segment it in different types of data, which in the next lecture we will be discussing what is vector, what is raster, and different types of vectors and other things. But we can segment the real world into maybe some layers of vectors might be having point line polygons, or maybe some layers of raster, maybe elevation information, maybe a satellite image representing the land use, forest cover, and all kinds of things are there. And then associated non-spatial data, or we call attribute data, or in simple terms you can think like a tabular data. So, you are having an object, and that object suppose this is x y, this is a one point, so it will have one x and y. So, it is having just location, it is a spatial data, but this point can have a table, attached a table like this, and can have say unique ID, which is essential for all spatial objects. Then you will have maybe the z location, maybe the owner, if it is a information about the house, maybe the owner, when it was constructed, and so on and so forth. Now, this part theoretically is unlimited, that number of columns which you can have in your database, in GIS database, standard GIS database, theoretically is unlimited, but when you are really using a GIS software, then there might be some software limitations are there. So, one has to be little careful while creating more fields against one single spatial object. Similarly, the same similar kind of table can also be in case of a road or a stream, which is representing a line or polyline, and similarly for an area you can have attribute table. So, attribute table will always store non-spatial data which is directly related with the spatial objects. It is not that it is lying in isolation, and that is the beauty of GIS, that spatial data and attribute data are having a direct linkage or a dynamic link or hot link. Otherwise, like in CAD systems, you do not have the database. Here you are having database as well as spatial objects. So, this brings to end of this presentation on components of GIS. As mentioned in the beginning, that in literature you might find few more components, but essential components I have already discussed here. Thank you.